Alright, so this is our new video on Chapter 5. We're going to start Chapter 5, Lesson 1. So hopefully you have gotten this package from the Google Classroom. Looks like this. We are done quadratics and we're on to trigonometry. Chapter 5 is our trig ratios and then sine law, cosine law. A lot of this you've probably seen before in grade 10. Chapter 6 is going to be all about graphing the sine function, so that's going to be new. But first, today's lesson is going to be our trig ratios. So what do I mean by trig ratios? I mean, whenever you have a right angle triangle, then we can use a trig ratio. If this is some angle, let's call that angle A, and we can use a trig ratio so ka toa. Do you remember that? Okay, so this means sine equals opposite over hypotenuse. So if this is the angle that we're considering, the opposite is over here. The adjacent, which is next to it, is here. And the hypotenuse, the longest side, is here. So this is pretty much saying that the sine of A equals opposite over adjacent, right? So SOA, ka, the cosine of that angle A equals adjacent over hypotenuse, and TOA, the tan, that angle A equals opposite over adjacent. So these are ratios and trig. So trig ratios. Okay, just a reminder, these can only be used on right angled triangles. If you do not have a right angled triangle, you cannot use your trig ratios. In those cases, we'll get into the lessons next week on the sine and cosine law, which you can use. But for now, let's use these trig ratios to go over some examples. Right. I'm going to go over the examples that's in your package, so follow along. The first example looks like this. A right angled triangle, angle A, B, C. C is obviously 90 degrees. And then our side lengths are 15, 12, and 9. Okay, and it says state the three primary trigonometric ratios for angle A. So here's angle A, so this is the one we're doing it for. So in this case, the sine of A is what? Well, sine, so, is SOH, opposite over hypotenuse. So the opposite angle, the opposite side to this angle is 12 over the hypotenuse, which is 15. Next is cosine. So the cos of A, okay, is so ka, so AH, adjacent over hypotenuse, so 9 over 15. And lastly, tan, TOA, is opposite over adjacent, so 12 over 9. So that's example 1. Moving on, example 2, it says find the value of C using the Pythagorean theorem as well as the size of angle A. Okay. So we have a similar triangle. The lengths are different. We have 3, 4. It's actually a nice triangle, so 3, 4, and 5, but we'll see how that works. All right, so if you're using the Pythagorean theorem, this is side C. So C squared equals A squared plus B squared. So 3 squared plus 4 squared. I think we're familiar with Pythagorean theorem. Okay, so 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. But that equals C squared. So we need to take the square root of both sides. And we get C equals 5. Well, when you take the square root of both sides, you should get plus or minus 5, but in this situation, negative length really has no meaning. So we're just going to take our positive value. So our value for C becomes 5. Now we have to actually figure out what that angle is. Now in this case, since we know all three sides, we could use any trig ratio we want. But let's pretend that we haven't calculated that yet. We could figure out this angle using opposite and adjacent. So which one of those trig ratios, so katoa, uses opposite and adjacent? Think about it. Pause the video if you need to. Okay, it's going to be tan. So the tan of A equals opposite over adjacent. Now when you're solving for the tan of A, we're going to write A is the inverse tan of 3 over 4. And then we're going to punch that in on our calculator. I'll show you how to do that. So this is my calculator. Yours might be slightly different, so try to figure it out. Okay, one thing that's very important, you should have up here a D. You probably can't see that, but a D for degrees, or some calculators say DEG. It should be on degrees. It should not be on R or G. Those are radians and gradians. Okay, so make sure it's on degrees first, or you're not going to get the right answer. Okay, now we want to write the tan inverse. So here I have my trig functions. I have sine, cosine, and tan. Now, it's hard to see, but just above them in yellow is tan to the -1, cos to the -1, and sine to the -1. So my shift button up here is also in yellow. So to push any yellow button, I first push shift and then tan. So you can see on the screen you get tan to the -1 bracket. And then in that bracket, I'm just going to put 3 divided by 4, an end bracket. So now it looks like this on my calculator. Okay, hit the equal sign, and I get 36.869 and so on. But I'm going to round that to 37 degrees. All right. So that means this angle is 37 degrees. Okay. Next page looks like this. Alright, so on this page we have 2 new terms. We have the angle of elevation and we have the angle of depression. Angle of elevation is just the angle that you're looking up at, so from here to here. Angle of depression would be the angle you're looking down at, so from the horizontal down, so this angle. In example 1, it says you're out in a field flying your kite. You have just let out all 150 meters of your kite string. You estimate that the kite is at an angle of elevation from you of about 20 degrees. Calculate the height of your kite above the ground. So the words that are in the question you could use to draw the picture yourself, but they do draw it for you. It's at the angle of elevation, so that would be this going up, is 20 degrees. The length of the string is 150 meters, and we want to know the height from the ground. Okay, so we have an angle, and we have one side. And this is a right angle triangle, so we can use a trig ratio to figure out the other side. So the 2 sides we care about are opposite and hypotenuse. The side which is adjacent to the angle, the adjacent side, we neither know nor wish to know. So which trig ratio involves opposite and hypotenuse? Think about it. It's our sine ratio. So we write the sine of 20 equals opposite over hypotenuse. And now if we want to figure out what h is, we just need to solve the equation. We can multiply both sides by 150. So we get 150 times the sine of 20 equals h. And now we're just going to plug this into our calculator again. Right, so you will write 150 times the sine of 20. You don't need to use a shift in this case. So it'll look something like this. And when we hit equals, I get 51.303 and so on. Right, I'm just going to round that to 51.3. And in this case, it's meters. Okay? Any questions? Put it into the Google Sheet. All right, example number 2. This has 2 parts, and then that'll be it for this lesson. Here we have a communication antenna. So let me draw this. Well, I'm just going to draw the triangle. It's a terrible drawing, but you get the idea. All right, this is 16 meters. The height is 12.5 meters. This is B, D, C, and A. Okay, that's good enough. Okay, and it says, what angle of elevation from the ground do the wires make? So that's this one, angle of elevation. Remember, so we want to know what this angle is, angle B. Well, if we're just looking at this first triangle, this one here, remember you can't do the whole triangle because that whole triangle is not a right angle triangle. So if we just look at this right angle triangle here, we can solve that. We know the opposite side to that angle, and we know the hypotenuse. We just went over that opposite over hypotenuse is our trig ratio. So we can write the sine of B equals opposite, 12.5, over hypotenuse, 16. Now to solve that, well, you can say what's being done to B? Well, the sine is being done to B. So the opposite of that is the inverse sine. So we're going to write that B equals the inverse sine of 12.5 over 16. And you'll put that on your calculator using shift, or some calculators are second function, something like that. Sine 12.5 over 16. And you'll get an angle of 51 degrees. Well, I rounded it to 51 degrees. Now part B says, how far apart are the points at which the guide wires meet the ground? So here's where one wire meets the ground at B, and here's where the other wire meets the ground. And so it wants to know that distance between B and C. Well, since they are identical wires, if we simply knew this distance, we can just double it and we'll know the whole distance. So let's stick with our red triangle here. And there are a couple ways we can solve it. It says solve using trigonometry and solve using Pythagorean theorem. So let's do trigonometry first. If we want to figure out the length of BD, right, that is adjacent to our angle. Okay? And which trig functions have adjacent in it? Well, both tan and cos do. And we know both the opposite and hypotenuse, so you can choose whichever one you want. I'll use cos. So the cos of that angle, which is 51, equals adjacent, that side, which I'll call BD, over hypotenuse, 16. Now if I want to solve for BD, multiply both sides by 16. And plug 16 times cos 51 into a calculator, I'll get 10.1 meters. That means this entire length is twice that, which would be 20.2 meters. Okay? Twice of 10.1 is 20.2 meters. All right, that's using our trig function. But we can do this using Pythagorean theorem. Remember, Pythagorean theorem also only works on right angle triangles, as long as you know any two sides. Now in this case, we know the longest side, the hypotenuse, and this side. So yes, we usually write it as a squared plus b squared equals c squared, but we're not always solving for C. Remember, C is always the hypotenuse. So in this case, C has to be 16. Right? And then you can choose either A or B to be our 12.5. So if we're going to solve for A, and we're adding 12.5 squared here, we'll need to bring it to the other side by subtracting it. So A squared will equal 16 squared minus 12.5 squared. All right, now if you do that, you get 99.75, and that's A squared. So square root both sides, and we get A is about 10 meters. Now if we double that, we get 20 meters. Not exactly the same, but the reason is, back when I took the cos of this angle, the cos of 51, the angle wasn't actually 51, was it? If you go back to part A, and you do the inverse sine of 12.5 over 16, just do that real quickly. So the inverse sine of 12.5 over 16, it's 51.37516,713. So if you want, you can try using that exact value, right? And you should get an answer that is the same as Pythagorean theorem. All right, so there is round off error, but that's all right. It's very, very close either way. All right? So that's it for that lesson. If you haven't done your Google form quiz for quadratics, make sure you do that first before you start doing the homework for trigonometry. Okay? This we will get more into next week. Okay? Hope everyone's well, and I'll see you next time.